And here we go. So, the Dread Pirate Roberts notices that when he tries to go straight across the river, what happens? He ends up going downstream. So the stream is still moving at 4 miles per hour. Nice catch, by the way. That was Alyssa, right? Yeah. I so owe you. Yes, you do. So, it was not. Stop it. All right. Which way, point with your physics pointing finger, will the Dread Pirate Roberts head his boat if he wants to go straight across to this pier over here? Excellent, yes. Not sure where that came from, but. And let's say that this time the boat is traveling at 5 miles an hour. So now the resultant is how big? The resultant is the blue one. 3, that's right, 3 miles per hour. That is correct. So the parallelogram method still works here. Look, if we take this and slide it over, hey, there she is. There's our right triangle, right? There we go. Got it? And what would this vector right here be? 4, right? Okay. So now let's do all those relative to questions. You ready? Yeah, I know. No, I don't. No, we're good. No, the boat's traveling. It's pointing to the left, and then it ends up going straight across. It's heading upstreamish, but the result is it goes straight across. So here we go. How fast is the boat going relative to the shore?
0.
Yeah, here's the answer, 3, 4, or 5. Hand in the air. How fast is the boat moving relative to the shore? The answer is either 3, 4, or 5. How fast is the boat relative to the shore? 1, 2, 3. That's the right answer. 3 is the right answer.
Well, wouldn't it be 1 because he's going 5 miles that way and 1 that way, so they cancel, and it looks like
No, you have to use Pythagorean theorem. No, yeah, I wish it was just that simple.
No.
Relative to the shore means not including the moving shore, which that's like saying the Earth hurtling through space. So do you include the river? Answer starts with a Y.
Yeah.
You include the river because I said relative to the shore, and when you say relative to, don't include that, whatever that reference is, right? So did I eliminate the river when I said relative to the shore? No, that's still in there. So boat plus river equals that, 3. How fast is the river moving relative to the shore?
4 miles per hour. 4.
Yeah, that's right, 4. How fast is the river moving is another way to say that, right? How fast is the boat moving relative to the river? 5, good. Relative to the river means shut off the river, don't include the river, and then what would the boat do?
Hit the wall of
The boat will just do this by itself, right? Last question. And this one, everybody hands in the air. Let's see if you really understand this. It's going to be a 3, a 4, or a 5. What number shows on the boat's speedometer? 1, a 2, 3. 5 is correct. 5 is correct. I should do what? In knots. Okay. Your speedboat is miles per hour? Okay. What if the Dread Pirate Roberts has a GPS with him? What will the speed on the GPS show? 3. Because the GPS is reference to what? Yeah, like start to finish on the land. And that would be doing this, straight across. Go ahead, Wes.
So if you're going up a hill in a car and you are attempting to go 40 miles per hour,
Yes.
the car will reach the gear which will attain 40 miles per hour, but your speed won't be
Yeah,
adjusted.
no, it's because it's the measurement of how fast the wheels are moving.
Yeah, the speedometer is based on how fast the wheels are moving.
So
So the engine has to work harder because it's going uphill.
Yeah.
But you will still be going, the speedometer is referenced to the ground.
So you will not be going 40 miles per hour.
Yes, you will be going 40 miles per hour compared to the ground.
But your engine's working.
Yeah,
So
that's
your
why
engine
we,
RPM will be.
yeah, if you look at the RPM, it'll be high, but your speedometer will be the accurate speed. So you may be going like 2,000 RPM, but your engine will be going
Yeah,
Engine
but
has no fault.
in this problem, you say the speedometer would read 5 miles per hour.
That's correct.
But the road's not moving.
But you're going 3 on,
cycles of the motor.
on a GPS. But see that, the problem is when you're doing the uphill thing, the hill just doesn't, the hill is immovable.
So it does not operate in every distance.
Yeah, but it's because the hill doesn't move. It's still resistance, and what Thomas said about the RPM, your motor has to work harder, but the speed is the same. Let's try this one. All right. A plane flies in still air at 200 miles per hour. That is pretty slow. It's a little plane.
It's a little.
So, and then it encounters a headwind. Headwind, show me, physics pointing finger, which way? Headwind. Yes, that is correct. And the headwind is 50 miles an hour. Relative to someone standing on the ground, how fast is the plane going? 150, right. Relative to someone sitting on the plane, how fast is the plane going? Yeah. What does the speedometer on the plane show? 200. What does the GPS that somebody's got with them show? 150. Yeah, bet. Yeah. Because,
Someone standing on the ground.
yeah, somebody standing on the ground sees the plane going how fast? Relative to the ground, the plane's going 150.
What if relative to the plane is zero because they're on the plane, so plane is not moving fast?
Oh, Liam, you are right. Dang you, Liam. Yeah, that's correct. I meant to reference just like what's the speedometer show. You are correct. Don't worry about that. If Liam confuses you, just pretend like he's the man behind the screen and ignore him. Go ahead.
It's really weird if like you had it like in a jet and encountered like a really, really, really fast headwind like in a hurricane or something and just stayed in like one place.
Yeah.
What if that ever happened?
Yeah.
But like in the air, it's just like.
Right. Yeah, like those pretend parachuting kind of wind tunnel things. Go ahead, Liz. Well, it depends on what you mean by actually. On a GPS, compared to the ground, relative to the ground, yes, it's actually going 150. That's probably what you mean by actually, like point to point, how fast is it going, right?